Greetings, friends. This is the second of two videos that will give us the very briefest of introduction to quantitative research methodology. And for this video, what we wanted to talk about was the bell curve and what is called standard deviation. The bell curve is a way of describing what is often called the shape of the data, of the shape of the distribution. And one way to think of that would be to use the example of what's called the bean machine. And you can imagine that at the very top of this, a bean was dropped, or a marble. And each time it hit one of these pegs, excuse me, the marble could go either one way or the other. Sometime it would go left, sometime it would go right. Now, in order to be able to fit way out here, it would have to go out left every single time. Left, 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 left. How often does that happen? Not very often. How about left, left, right, left, 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 left? Sometimes, more often, but not so often here. So you can see that most often it would go left and right, left and right, left and right, which statistically would be what we would expect, which is why most of these marbles fit in the middle. So this bell curve applies to a number of different kinds of situations, not the least of which is often human behavior. Human behavior is often distributed evenly along a bell curve. And we can point to literally millions of examples of that, from certain kinds of performance abilities to intellectual capacities to emotional tendencies. This is how those kind of behaviors tend to be distributed. Now we'll show you some examples of exceptions to that in just a moment, but that is the basic assumption of the bell curve, is that most people tend to be normal or average. Now, when we measure this along what's called standard deviations, and we'll get to a specific example about that in just a minute. But what you'll see here is that inside of the bell curve, closest to the mean is where most of the population lands. We say that they are the same as others. The further away you get from the mean, the less like each other they are, but they are more like others than not. And way out here, the individuals who are at the extreme of one end of the bell curve or the other are less like others. Now, how does that happen? So let me give you an example of how that might occur as a result of a particular test. And in giving that test, you score it. And you might get any number of numbers. And so I just randomly scored a hypothetical exam and put all the numbers out here. If the particular class or the group that was given this assessment is typical, then most people would get an average score. Some would do a little better. Some of you do quite a bit better. Maybe one person nailed it. Same thing would be true on this side of the bell curve. And this is what's called a typical or normal distribution of the bell curve. Now, what if you only had a few individuals that you gave that assessment to? We have statistically the ability to infer from these scores that you have what the rest of the population might look like. And this really is at the heart of statistics, is making these kind of assumptions based on small samples. And you might have seen during election time, people who do this kind of work say that there's a plus or minus 3% chance, or we have a 95% confidence interval. We'll talk about that a little bit later in the course, because nothing can be sure until you take every score of everybody in this population group. But if you have a representative sample, you can get a fairly good idea what the mean or the average of that sample group is. Now, not every group is so nicely distributed. This is a normal group with a normal distribution, but sometimes you can get things that are skewed positively. It means there's more extremes out this way, sometimes more extremes out this way. It's called negative skewing. Now we showed an example in our last video of a kind of a skewed distribution. It wasn't a nice normal distribution. Wouldn't that be nice if it was? But in this case, it's skewed positively. More people out here at this end of the scale. Some other examples of that. We talk about when we talk about things being skewed, we talk about the tail that it's skewed towards. This is the negative tail. The long tail exists on this side, and I just gave you an example of that. This is a chart which talks about the age which married men die. They tend to live longer than their unmarried counterparts, but the tail is skewed negatively. Here's another example of a job that was opened and the number of applicants who completed the whole application process. These are negatively skewed scales. We already gave you a positively skewed scale. This is another example of how many slices of pizza students eat, right around here, and positively skewed in this direction. So this gives you just the basics of standard deviation. The assignment for this week will take this idea of standard deviation and show you a very practical example of that with the work that Marzano does in educational research. But before we leave this topic, just wanted to make a point about this bell curve and the assumptions behind it. The bell curve can give some helpful information when talking about how a group is normally distributed. And we make a lot of use of the bell curve when we talk about average scores and our assumptions about what that means for a particular population group. But it doesn't tell the whole story. If we talk about a standard deviation, let's say this was a score on an assessment for a particular gender group or ethnic group, it might tell you how that group scores as a whole, and you may want to make some policy adjustments because of that. But it tells you absolutely nothing about any one particular person that you might meet from that particular group. And that's the important thing for researchers and educational professionals and policymakers to keep in mind, because it obviously is so easy to become biased because of a mean score on a assessment piece about what any one particular individual in that group might be like. And it's important for us as researchers to make sure that in talking about bell curves and standard deviations and distributions, that we understand that when we're talking about these, we're talking about groups, and that doesn't provide us any helpful information when talking about any one particular individual in that group. They may be an outlier in this direction or in that direction, and we wouldn't know unless we got to know them better and saw their particular performances. And so that's one thing that's always good to keep in mind. There's several books that are written on the topic. This one particular book caused quite a controversy in his application of the bell curve in a socioeconomic sense. There's a book that was written to follow this up that talks about all the mistakes that can be made when we rely too heavily on it. Well, hopefully that provides a nice basic introduction to what we're going to be covering in the next several weeks and some of the terms that are going to be important for us.